My name is Pauline Provini. I'm a French biologist and I work on the evolution of dinosaurs, which means birds. I'm interested in how birds are producing sounds, and so my project here at the CRI is to understand how birds are producing the amazing diversity of sounds that they are able to produce. And the long-term goal is to build efficient vocal prostheses for people with laryngectomies. So currently in the team there are two postdocs working with me. Rachel Olson, who is a biologist, and she's interested in understanding the motion of the soft tissues. And Ali Reza Kazemi, who is a physicist, and he's going to work on the modeling part of the project because his background is on the modeling of human lungs. There are also interns that are working in the project, especially interns from the graduate program of the CRI. I collaborate mostly with the Museum of Natural History in Paris. They provide access to bird collections, which is very important for the anatomical part of the project, but I can also film birds, which is also very important to understand how they vocalize. I'm also trying to build a collaborative network with medical doctors, patients, and all the people that would be interested in building the vocal prostheses. I'm interested in understanding the mechanisms that shape the evolution of animals. So for that, I need to understand what the structure of the animal is during the evolution. So sometimes I need to look at the ancestors of the living animals, but also I'm interested in the motion that they are able to produce. And for that, I need to film them and understand how they move and with what structure they are able to move. So this is what functional morphology is all about, making the link between shape and function. We have a lot in common with birds. We don't necessarily think about it every day, but they walk on two legs as we do, and they are also able to use complex vocalization to communicate. And I think that birds are a unique opportunity for bio-inspiration. This is why I want to study birds to produce new vocal prostheses. So the current vocal prostheses that are used for people who got a laryngectomy, so who had an ablation of the vocal cords, they are great because they allow them to speak again, but at the same time the voice that is produced is very weak with very low frequency, and this is a problem for the patients, especially for women, because the voice very sound like a male voice. So the idea is to look with my team at the different mechanisms that birds are using to produce sound, and to use those principles to produce a new generation of vocal prostheses that would be more efficient and that would produce more human voice. So the birdsong team use cutting-edge methods to gather the data that we need for our research. So for example, we use medical imaging such as CT scanning to see the internal, we use medical methods of imaging such as CT scanning to see the internal part of the body of the birds. But we also want to see the different motions that the birds are doing while they are singing, and especially the internal motions. So for that we use high-speed X-ray videos that allows us to see inside the body while the birds are singing. Of course, healthcare would benefit from the work that we're doing in the team, but I think that any field interested in the relationship between form and function could benefit from our work. I'm thinking about scientists, but also non-scientist people, such as designers or artists, like musicians or singers, for example.